Howdy folks, so in this pre-work we're looking at sections 1.4 and 1.5, so we'll start with 1.4. And here we look at the topic of separable equations, and so here we're going to learn how the technique of what's called separation of variables. So in class I'm going to be much more careful and justify these steps as to why they work, but for right now we're just going to do some symbolic manipulation that arrives at the same answer that the careful work will. So we'll just go ahead and show that work, and then we'll justify it in class. So here we're given a differential equation. It's a first order. In fact, we go ahead and classify it as a first order. In this case, it's also linear and linear ODE. And I'm also going to add the fact that the function or the equation is separable, and I will define that in just a moment. But let's go ahead and actually start doing the manipulation here. So when you have a separable equation, it means that it's possible to separate the variables onto either side of the differential equation. Let's go ahead and do that now. What I'd like to do first is I'm going to multiply the differential x to both sides of this expression, and then I'm going to divide both sides of the expression by y. So that gives me 1 over y differential y is equal to negative 6x differential x. So I multiplied both sides by differential x. That's how that differential x came to be on the other side. And I divided both sides by y. So the next step is to go ahead and integrate both sides with respect to their given variable. And this is the step which you should feel a little bit squeamish about, and I will justify this step more carefully in class. But now we're just going to say let's integrate both sides. And when we do so, integrating the left-hand side gives us the natural log of the absolute value of y. And I'm going to purposely leave off my constant. And we're going to say that that equals negative 3x squared. And here's where I'll put a constant. And really that constant is the constant that I got from integrating the right-hand side and the constant that I got when I integrated the left-hand side. I just put everything over on the right-hand side there. So we've actually solved this differential equation. We now have what we called in class an implicit solution. So we've actually now solved this differential equation. We have what we called in class an implicit solution to it. And now what I'd like to do, though, is actually give the explicit solution. So for that, we're going to have to solve for y. I'm going to do a technique here very carefully that we're going to see over and over again in this class. So this is a great time to pay attention to that. What I'm first going to do is I'm going to first raise each side by the power of e. So that gives me e to the natural log of the absolute value of y is equal to e to the negative 3x squared plus c. So first of all, on the left-hand side, we're just left with the absolute value of y. And on the right-hand side, I have this expression here. And for this time only, I'm going to do some algebraic manipulation of this, and then you'll see that later on, we'll usually just skip a couple of steps. So first of all, I'm going to rewrite this as e to the negative 3x squared times e to the c. Okay? Well, what is e to an arbitrary number over here? It's again an arbitrary number. So I could actually write this as the absolute value of y is equal to, maybe we call it some new constant, c1, e to the negative 3x squared. Now in this class, and most people that are integrating or applying the technique of differential equations just go ahead and they're very sloppy with their constants. So I will still just call this c, even though this is a different c right here than we had before, because this c actually represents e to the c. And so here we're well on our way to having solved this for y. The next thing to do is to remember that when you go to solve something for in an absolute value, one way to do so is to say that y would be equal to plus or minus c e to the negative 3x squared. But of course, c is an arbitrary number, and the positive version of that arbitrary number or negative version of that arbitrary number is again arbitrary. And so finally, at long last, we just get a solution of y of x is equal to ce to the minus 3x squared. So, folks, there we've solved a differential equation through the technique of separation of variables. The key thing to keep in mind is that we recognized, hey, it's possible for me to divide the y function over to the other side, and I can multiply the differential x over to the other side, so I end up with a function of y dy is equal to a function of x dx, and then This part should be a little disconcerting. We'll explain this in class, but we go ahead and just integrate both sides of these equations. Finally, we're left with something that we need to solve for if we can. So there's an intro to the technique of separation of variables.